Hello, my name is Alois Jungbauer. I'm here in Sitges, Spain, attending the conference Integrated Continuous Biomanufacturing. And I have the pleasure to interview three people who are very active in this field. Yeah? Kevin Brouwer, a young scientist from Sanofi, Chetan Goudar, an experienced scientist from the company Amgen, and also Konstantin Konstantinov, the person who has really pioneered the field of continuous integrated biomanufacturing. To which extent has integrated continuous biomanufacturing changed the landscape of the biopharmaceutical industry?
So thank you for the opportunity to speak today, Professor Jungbauer. I should start by saying that these views expressed today are mine, although I'm associated with Sanofi, so happy to answer your questions. And the field of continuous biomanufacturing has really changed the way we think about bioprocessing. I think it allows us to look to a future that's different from the batch past and enables us to think about how we can intensify our processes, how we can disrupt the way we design manufacturing facilities, and ultimately how we can get patients their medicine faster, quicker, and more cost effectively.
Great. And so what has accelerated and what has inhibited the faster implementation of integrated or continuous biomanufacturing? Could you comment on this?
Yes, so I would say the challenges. I think in terms of implementing continuous manufacturing, we deal in a situation where we have installed infrastructure present that's often batch, very large scale stainless steel that we'd like to utilize fully so we can take advantage of past investments. And then the second area I would say is because continuous manufacturing is such a different way of thinking and requires different skills, there is some time for the workforce to transition from the training and the understanding of how to design processes of the past to that which we'll use in the future. Now, I'd say some enabling factors that have allowed us to go faster is collaboration with industry, academics, as well as with suppliers. And I think a week like this is a great opportunity where we can share ideas and really try to bring some harmonization to our approaches so that when we go back to our respective labs or our companies, we're able to take some central themes and bring those to practice in our respective companies.
Thank you. Could you comment on training networks and how important they are for industry? And if you know CODOBIO, could you comment on CODOBIO? And is actually there a shortage in training programs and in young talent for industry? Yeah?
So we could always use more talent in biotech and especially in bioprocessing. I'm aware of the CODOBIO efforts and a number of the students that have come through the program, number of which will be here this week. The important thing about CODOBIO and a lot of the training programs that have been established is that they're working on real world problems that will solve the future and enable our future. And so I think the need is tremendous. And I would say it's not just for CODOBIO and for students that are in graduate school, but for the entire workforce. You can imagine the training that an operator might need to work on the floor is going to be different than what they might have done in the past, manipulating filters or bags or all of that. And so I think the industry is just in the beginning of transforming how we're approaching training our talent. And there's room for more work like CODOBIO at all levels of talent that enter a company.
Oh, thank you for your comments, for your view on continuous biomanufacturing on our training network, and I'm sure our students will be pleased to hear that they have been on the right track.
Precisely. Thank you.
I'm pleased and very thankful, Chetan, that you are willing actually to share your vast experience in bioprocess engineering, and especially in integrated continuous biomanufacturing with us. Could you introduce briefly yourself, your background and your career?
Yeah, sure. Alois, thank you very much for having me here for this discussion. I'm a chemical engineer by training, and I started working at Bayer Healthcare in 1999. And that's where I first started to do perfusion work, working on recombinant blood factors, very unstable molecules, and we really had to have perfusion upstream to make the molecules and keep them stable. But then later on, the field evolved, and we have moved on to integration of continuous bioprocessing, where not just the upstream, but the downstream and everything else is also continuous. And that's the work I've been doing for the last 10 years or so when I've been at Amgen.
Can you explain us a little bit about how continuous integrated manufacturing has changed the landscape of biomanufacturing, the impact in industry, but also society, and also, let's say, the accessibility of drugs?
It's made a big difference. When this concept was first introduced, it was not very sure if it was just a technological advance, what the impact would be. That was not clear to everybody. But as we have seen it evolve in the last 10 or 12 years, we have seen very significant impact. The most important one for me is you shrink the size of the manufacturing plant. And what that helps us is, instead of investing billions of dollars in building a manufacturing plant, you can invest 10 times less money, and you can right-size the plant as to what you need. And that now is enabling more companies, like smaller companies who would never do manufacturing on their own before, now have the ability to take this technology and then deploy a plant to make clinical product and also commercial products. So that's one significant advantage. The second thing is, because you run at steady state, product quality, you also are able to now control product quality better. And for certain kind of molecules, it really is the preferred format of choice. But for me, intensification helps reduce investment costs. It helps reduce the speed with which we can build manufacturing plants. And in addition to those cost benefits, it also motivates our scientists and engineers who work in our teams. They're developing new technology, and they come to work to really work on state-of-the-art methods too. So this really helps us.
What are the burden to implement such a continuous integrated manufacturing strategy in a company? Yeah.
So one big burden that we encounter is, some companies have an established network of large stainless steel plants, and they always want to utilize them fully before they decide to invest in something else. And I think it's an understandable concept, because they already have made the investment. So that's one thing that we have seen was a burden 10, 12 years back. But now what companies are realizing is that is not the only way, there is a better way. And they're now starting off by implementing a clinical manufacturing plant first, and with the intent to maybe build a commercial plant later on. But that I see as a big burden. Also, sometimes people don't fully understand. It looks very complicated to certain people. It seems very different, it seems very new. And I think that requires education. We just have to be patient and explain to people, why is it different and how does it benefit? And that's happening, but I still think there's some more work that needs to be done.
Could you comment on training and education? You mentioned educate within the company, but you also need actually trained people, because we have established this training network. Could you comment on is there a shortage of trained people in this field, and how actually do you see training networks?
That is maybe one of the most important enablers of this technology in industry. In the early days, we had few people who had worked in certain companies who had the training. There was not much academic training happening, 10, 12 years back. And that was also a problem for us, because we couldn't find someone who had done it before who could come in and help us. But now I think, thanks to the work that you and many of your colleagues in Europe are doing, it is phenomenal work. I think you have some of the best training options for students across Europe. And we benefit more than you, because we now get students who have gone through the training courses, they understand the principles, and I think in many cases they know the state of the art better than what we do. And when they come and work with us, one is, it's motivating for us to have someone who comes in and says it can be done. They teach us, we teach them a few problems we have had, and it's been a big help. I still think more needs to be done. I think we need more students who need to be trained so that they can help the broader industry. But the work that some of you have done the last few years is truly phenomenal, and I'm very appreciative of that work.
Okay, thank you for this feedback, and I'm sure our students or our graduates will appreciate this comment. Yeah, they will, what I see, have no problems to find a job. Yeah, some of them have been hired even before they have graduated, which is also a critical thing. Yeah, no, thank you, Chetan, for this interview and for your sharing your insight in continuous integrated manufacturing and manufacturing of biopharmaceuticals.
Yeah. Thank you for having me.
Yeah.
Thank you.
Okay, thank you.
Thank you.
Yeah. Real pleasure for me today to have Konstantin Konstantinov, and I'm really thankful that you are willing to share your thoughts on continuous integrated biomanufacturing. Konstantin is considered as one of the pioneers of this field. Yeah? Please, Konstantin, introduce yourself, yeah, your background, and actually your role in industry.
Yeah, thank you, Alois. Very briefly, I'm biochemical engineer by training for already 30 years in industry. I have worked for a few large companies, and recently for 6-7 years in a small company in Cambridge, USA. Our platform is exosomes, biological nanoparticles, and my responsibility is process development, analytics, manufacturing, such kind of activities. So my role in the company is Chief Technology Officer.
Okay, thank you. I remember, was it 2012, yeah, in Berlin, yeah? I invited you for keynote lecturing, a lecture at the European Conference of Applied Biotechnology, yeah? And you gave a great keynote lecture. You did also some forecasting, promises of continuous integrated manufacturing, yeah? At that time, we have written down the interview, which was good, yeah, because everybody can actually read, yeah, what actually vision you had about continuous integrated manufacturing. Can you briefly explain us or share with us what really came through of your vision to have an integrated continuous biomanufacturing?
I remember. It was in the big Congress Hall, and it was a pleasure to be there, and thank you for organizing this interview. Interestingly, I would say on the positive side, strongly positive side, we have realized many of the things that we hope to achieve, but not all. At this point, we have quite a few bioprocesses in the world run continuously. This started with proteins, recombinant proteins, and antibodies, and now it's expanding, broadening into complex new modalities. Very encouraging. Some of these processes are partially continuous, upstream and part of downstream, and recently, over the last probably year or so, we hear now for many implementations of what people call end-to-end. This means the entire process train is continuous. Now, this is happening. We have a much better understanding of the technology. The technology definitely is maturing and is accelerating much more rapidly now. What has not happened? There are a couple of things. First, probably not surprisingly, everything is progressing slower than we hope. But if you look at other industries, and there are many other industries that have transitioned from batch to continuous, the speed is always a problem. For example, steel industry has transitioned to continuous for about 100 years.
Wow.
I hope this is not going to be our case.
100 years, yeah.
We're doing okay for 10, 15
for 10,
years.
15
yes.
years, yeah.
And yeah, we're doing really very well, but we are impatient because the concept, the vision, and the drivers, people like you in academia, other folks in academia and industry, they really are committed to do that. There is some momentum, but we feel it's slow.
Okay, that's interesting. So now let's come to a training of young talent and actually to a shortage of workforce. Yeah, that's actually is, always reported. Yeah. Could you comment on training networks in the field of biomanufacturing and in particular continuous biomanufacturing? Yeah.
I think I'm in industry, so I'll represent this viewpoint. We always need more training and more people, especially recently over the last couple of years. It has been very difficult, maybe in my area, Cambridge, close to Boston, and maybe in your area, very active in this field, to recruit people because it's a great competition for talent in general, number one. Number two, if we talk about continuous operation, it will be fantastic if we have people who are trained in this. What does it mean? It means to me that the people will have a good training in upstream operation, cell culture, but they will have also very good understanding in downstream operation. So much broader background. Not that their background is the same everywhere. No, they have a peak, maybe cell culture, maybe downstream operation, but much broader spectra of understanding and skills that students that are trained more narrowly, only in cell culture or only in cell line engineering. We need people with broader background.
Yeah, and actually, could you also comment on the interdisciplinarity? Yeah, so bioprocess, we need the bioprocess engineers who understand control engineering, who understand also other disciplines. Yeah, that's
yeah. We always look for super people,
yeah.
super employees, but it's unrealistic to expect that somebody who is coming from university will have very deep skills in all these areas, but at least to have good understanding, some fundamental systemic thinking which is healthy and correct. We'll continue the training of the person. The person is going to train himself or herself in the company, but to have the right foundation is very important. Yeah.
Do you agree that our graduates or these graduates trained in this field will have a good future?
Knowing you, I have absolutely no doubt.
Okay, good.
Because I know you as a person with very broad professional interest, depth and curiosity, also creativity, and there is no way that this is not really translated and given to the students. But everybody is a different individual, so people take it probably differently. But I know your university has produced some fantastic people, is spinning off a lot of companies, and publications and presentations have always been top notch. So I believe you're producing the right resources.
Okay. So thank you for sharing your insight and your time. Yeah, I think the students will highly appreciate your comments and also they, I'm sure, appreciate your visionary thinking.
Yeah. Thank you so much. Thank you.